Hey everybody, today I just wanted to do a video about the different types of graphing tools available in LabVIEW, so what the differences are, how to know which one to use for what you're trying to do. So I kind of want to highlight these three in this video. So that's going to be the waveform chart, the waveform graph, and the XY graph. So if we go open the graphs section of the palettes, you can see that there's more down here. So we've got intensity charts, digital waveforms, mixed signal, error bar plots, and then there's a whole bunch of different 3D graphs as well. So all these other graphs exist. They're just not as commonly used as these main three. So these are the three that are, in your typical use case, these are what you're going to be using the most. That's not to say that these other ones are not used, but they're a lot more niche, not as common. So if you understand these three, that's going to work great for 90+% of your applications. And then when you do need to look into maybe like a 3D graph or like an error bar plot or something like that, there's great examples to learn those as well. So I just wanted to highlight these three for now. So let's start out with our waveform chart. So our waveform chart is basically a way that we can continuously monitor data. So it's going to hold a circular buffer in memory of some amount of data, and we can write that amount of data, and once we've exceeded that amount of data, it's going to start discarding the oldest data and replacing it with the newest. So you get what's called a circular buffer. You can continuously be updating it. You don't need to write all of the data to it every time that you write data to it. So let's do just a quick simple example. So I'm just going to use the random number function and pass that in, and I'm just going to drop a simple while loop around here, and let's add a stop button, and we're going to add just a little delay here so it's not too fast. Sweet. So I can write data, and you can see I'm only writing a data point at a time. So as I generate a random number, I'm writing that single random number. It's holding the previously written data in memory and just pegging on data to the end. And then, the graph is showing 100 data points, so it's going to continue scooting that data over and over and over again. There is, I can go back to 0, and you can see I still have all of that data even though it wasn't shown. So the chart has a fixed amount of history. So if I right click on this chart and go to chart history length, it'll show me what that length is. So by default, these are going to store 1,024 data points before they start erasing previous data. You can go in here and you can change that to basically whatever value you want. So for this demo, I'm just going to set it to 10. Now let's rerun that, and you can see I fill up my 10 very quickly, and I'm only holding 10 data points. So you can kind of customize that and tailor it to your specific application, what you're trying to do. Charts are just a great way for your continuous monitoring, where you're updating things at a consistent basis, and you want to have some sort of history of all of the data. Charts are your way to go for stuff like that. Now, graphs are a little different. So graphs are a way where you can basically dump a whole bunch of data into it, and it's going to display all of the data that you've shown. So a chart, you're basically defining beforehand how much memory you want in a circular buffer. A graph is different in that I can just basically dump data into the graph, and it's going to display everything. So whether that be 5 data points or 1,000,000 data points, it's going to be able to graph all of that data, provided you have enough memory. So these ones are just a little different. So I'm going to demo this. So let's just create a for loop, and let's generate our random number again, except this time we're going to build an array of all of these random numbers and then write them to the graph. So, and then let's say we want 100 data points. So here we're just going to generate a random number, use auto indexing to build that array, and then dump it to the graph. So we can run this, and you see our data appears just like you'd expect it to. We've got our full 100 data points, as you can see. And if I go and write again to it, it completely erases everything that was previously in that graph, and I get an entirely new data set of the new 100 random samples. So graphs are great when you have data. Let's say you read it from a file or something, or from a database or something like that, and you just want to pop that up in a graph so you can analyze it. Graphs are fantastic for things like that. Your continuous monitoring, typically you're going to want to use a waveform chart. Graphs I think are great where you maybe captured a waveform and you want to display it, or you're reading data from a file and you want to display that entire waveform. They're great for things like that, not so much your continuous viewing. And then the last one I wanted to show is the XY graph. So this is similar to the graph in that it's going to just display whatever I dump to it at the moment, but it works a little different. So in our graph, we're only really writing a scalar that represents the y-axis value, and it's automatically incrementing our x-axis by 1 across every sample. XY graphs actually allow you to put a pair of basically x and y values together and then graph them. So let's take a look at what this looks like. Let's create another for loop, and we're going to drop a random number down, and let's do get date time in seconds. So we're going to do this, and we're going to build an array of both of those. And then to graph this in our XY graph, we're actually going to bundle these together. So I'm just going to drop a bundle function, and basically the top of this bundle is going to be my x-axis, and the bottom one here is going to be my y-axis. So I'm going to be graphing time on the x-axis, and this random number is the y-axis. And then I can just tie that into my graph, and now I have XY pairs. And I'm going to add a little delay to this. Sweet. So and let's set this to run, let's say 5 times. So let's go run our example and see what it looks like. So you can see I get my 5 data points, and they are matched up. This is in number of seconds down here. You can also just go and here, let me show you. If we go to properties, I can just go to display format. So right now it's set to automatic formatting, which is going to switch between like scientific and floating point and SI notation for me. If I want it to view in units of time, I can just click absolute time or even relative time, and it changes that for me. So if you didn't want it in numbers, that's fine. You can change that. That way I have time on my x-axis and data on my y-axis. And I also just wanted to show really fast that this isn't exclusive to just time. So I also can plot like a XY pair of anything, right? So I can have 2 scalars. So I have a random number that will be an x and a random number that will be my y, and they become an XY pair. And I can run that. And there you go. So you get all sorts of funky shapes now as you run these different XY pairs. So that's kind of the main difference between these 3 types of graphing indicators. So the way I like to think of it, just kind of in review, so charts are great for your like continuous monitoring. I want to be continually writing bits of data to a graph and see trends and stuff. Graphs are awesome when I just need to dump raw data onto a graph and look at it. And then XY graphs are useful anytime you need to pair up X and Y data. So either I have timestamps and an amplitude data, or if let's say I want to plot flow versus pressure or something like that instead of like flow versus time. Well, then I can create whatever XY pairs I want. So those are going to be your 3 most common types of graphs or graphing tools in LabVIEW. So I hope that's helpful, and thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.